For the second half of chapter 9 here, well, 9.6, we're going to look at how we convert the equations we graphed yesterday from polar into rectangular. So it all comes from this picture again from chapter 8. We have a few equations we can use. So that one's pretty easy there. We also said that the sine of theta is y over r. So we said y is r times sine of theta. And by the same idea, we said x equals r cosine theta. And we also used that tangent of theta equals y over an x. But I don't think we need to use that so much with these graphs in here. Okay, so make sure you're able to get those three major equations. So what we want to look at is actually this last example we did on the previous lesson. We tried to turn this into a 1. We found it was a hyperbola. We plugged in our four major values on the axes. We graphed some points. We found the center. What if we want to take this in polar, so with r's and thetas, and we want to change it into x and y's, which we did the first half of chapter 9. So we should be able to do that. Down here, I put our little formulas that are going to help us. This is what we did right before break, and I gave you guys one quiz on it, but haven't tested you on it or seen anything since. So there's different strategies we can use to get to these substitution things. Sometimes we squared both sides, sometimes we multiplied by r's, and we did some substitutions. So if you look at this and you say, okay, well, if I take this and I turn it into an r squared, I got to turn this into a 2r. So this is another 2r, and then this becomes 4r sine of theta. Okay, that's perfectly allowed with what we're doing with math. The only problem is you can do substitution for r squared. You have something there. You can do a substitution for an r sine. You have something there. But what do you do with these guys here and here? So that would require you multiplying by another r or squaring. So that's probably not the best thing to do. What we're actually going to do in this case is take this and multiply it across and see what happens. So that's the exact same thing. If we distribute now, we have one substitution we can do. An r sine is the same thing as a y. Okay. The trick now is to get these r's by itself. So I'm going to swing this 4y to the other side. And what you can do, square both sides now. So you won't have to worry about getting a singular r. So what happens, 4r squared, 2 plus 4y times another 2 plus 4y. Okay, I'm going to pause it here and get us a new clean slide where we can finish this guy. So again, the trick is not multiplying everything by r, but doing the one substitution you can here and then squaring both sides. Because if you find yourself with terms with just an r, step back and see if you can get it isolated to something like this in the blue and then squaring both sides. So this is where we left off. We know an r squared is the same thing as an x squared plus a y squared. Double distribute this right side. copied that wrong. Sorry about that. Now it's all fixed up. We should be good to go. Again, when you're trying to do quantity squareds, please write them out as two things, product of two different parentheses, so you don't miss your middle terms. That's something we should definitely know what to do. So when we double distribute this, we gotta fix this guy. So 4 plus 8y, we come in here, add another 8y, and then we come out here for 16y squared. Now this should look familiar to something we saw in the first half of chapter 9. It's got x squareds, it's got y squareds. We just have to get everything basically on the same side, and there's some variations with how you can leave these. So I'm going to subtract a 4y squared. I'm also going to subtract a 4x squared, even though there isn't one over here. So now this is going to equal 0. 4 plus 16y, 12y squared, minus a 4x squared. Group these things a little bit better here. Now, the answers are going to be okay to leave like that, but it's up to you if you actually want to complete the square and make sure you get this thing correct. If you take a look at this now, we see it's got a y squared minus a 4x squared. So in rectangular, that means they should be a hyperbola. The y squared is the one that's positive, so it should open up on the y-axis, which is exactly what happens. You could swing this 4 to the other side, pull out the 12, complete the square. Numbers get a little ugly there because those aren't perfect factors there, and go from there with it. Okay, but basically, if you can do everything we just did, that's what I'm going to ask you to do for the second part here. I went and grabbed the picture from the last lesson where we took this same problem in its polar form here and ended up with this, going through our 6 steps. Now, if I complete the square with this, I should get the exact same thing. So you can see the hyperbola, it's opening on the y-axis because that's the one that's positive. Okay, so there should be some good connections there between rectangular and polar and things we've been doing the last couple weeks. We'll see you guys tomorrow with questions.